Welcome back, everyone. We're diving into some really cool stuff today, all about human behavior.
Oh, yeah.
We've got lectures on learning, memory, perception, even a little bit on evolution and how that ties into.
It's going to be fascinating.
It is. So to kick things off, let's talk about learning. We learn new things all the time, right? But
Yeah.
how does it actually happen?
Right. Yeah.
We take it for granted, but
Yeah, we do.
it's pretty remarkable when you stop and think about it.
Yeah, it is.
So we're going to start with two fundamental concepts: classical and operant conditioning.
Okay.
They might sound kind of technical, but bear with us, because they're actually pretty easy to grasp once you see them in action.
For sure, with some examples.
Exactly.
Yeah.
So first up, classical conditioning. Anyone heard of Pavlov's dogs?
Oh, yeah, classic example.
Right. So these dogs, they would start drooling whenever they saw food.
Like you do.
Exactly, a natural response.
Yeah.
But Pavlov, he paired the food with the sound of a bell. And guess what? Over time, the dogs started drooling just at the sound of the bell, even without the food.
They learned the association.
They did. They associated the bell with the food.
Right.
And what's even more interesting is that if you keep ringing the bell but stop giving them food,
The drooling stops.
the drooling decreases.
Right.
It's called extinction. That learned response starts to fade away.
Yeah, makes sense.
Now, here's the key thing about classical conditioning.
Right.
It's all about involuntary responses.
Like reflexes.
Exactly.
Yeah.
You don't consciously decide to drool when you hear a bell. It just happens automatically.
It's an instinct.
Now, another classic example, and this one's a little bit ethically questionable by today's standards,
Oh, right.
is the little Albert experiment. So this baby, little Albert, he wasn't afraid of white rats.
At first.
At first, no, not at all. But the researchers, they paired the rat with a really loud, scary noise.
Oh, no.
And you can guess what happened. Little Albert started crying and showing fear whenever he saw the rat, even without the noise.
Poor little Albert. But also, wow, powerful stuff.
Right. It shows how powerful these associations can be, even with something like fear.
Learned fear, yeah.
So both of these examples, the dogs and little Albert.
They both learn to associate something neutral with something else.
Exactly. Something neutral becomes linked to something that triggers an automatic response.
A bell, a white rat.
And that changes their behavior.
Totally.
Okay, so that's classical conditioning in a nutshell. Now let's move on to operant conditioning.
The other side of the coin.
This one's all about learning through consequences, through rewards and punishments.
Choices and consequences.
Precisely. It's about voluntary actions. Like, think about learning to drive a car.
Oh, yeah, good example.
You make a mistake, you stole a car, it's frustrating.
Definitely frustrating.
But then you figure out the clutch, the car moves smoothly, and it's like,
Uh-huh.
got it.
Yeah.
Exactly. That's positive reinforcement.
Making you want to do it again.
Exactly. And eventually, it becomes second nature. You don't even think about it anymore.
Until you switch to a car without a clutch
And your foot's still searching for that pedal.
muscle memory is wild.
It is. But it's a good example of how operant conditioning works.
It shapes our actions.
It does. And it's not just big things like driving. It's happening all the time with everyday stuff.
Like what?
Like checking your phone for notifications.
Ooh, yeah, that dopamine hit.
Right. That little ding, a new message, a like, and boom, a little reward.
It's designed to keep us hooked.
It really is. So I've got these two building blocks, classical and operant conditioning. But what about more complex learning, where it's not just simple associations or rewards and punishments?
Right. There's got to be more to it than that.
There is.
Layers.
Exactly. So next time, we'll dive into some of those more complex forms of learning.
Can't wait.
Stay tuned. Okay, so we've talked about how we learn, but what about remembering what we've learned?
Memory.
Right. It's like we often talk about memory as this perfect recording of our experiences.
Like a video camera.
Exactly. But is it really that simple?
I don't think so.
Yeah, me neither.
It's way more complex than that.
You know, I was thinking about this. I heard a story once about these three friends,
Okay.
and they were watching a satellite move across the sky.
At night?
Yeah, at night.
Mhm.
And each one of them was absolutely convinced they were the first one to spot it.
But only one of them could have been.
Exactly. So what's going on there?
It's a great example of how our memories, even when we're trying to be accurate, they can be shaped by our own perspectives
And our desires.
and desires. Like, we want to be the one who saw it first.
Right. And what's really wild is each friend probably genuinely believed their version of events.
Oh, absolutely. It's not like they were lying.
No, not at all.
Their memory had literally been rewritten to fit that narrative.
So it's not just about the facts. Right.
Right.
It's about how we weave those facts into a story that makes sense to us.
A story we can believe in, yeah.
Okay, so if our memories are so malleable, how can we even be sure of what we remember?
Right. Like how much of it is actually true.
Well, this is where the work of Elizabeth Loftus comes in.
Oh, the memory expert.
Exactly. She's a cognitive psychologist who's done some amazing work on the fallibility of memory,
Fallibility meaning.
meaning that it's not perfect. It can be wrong, it can be influenced.
She's shown that in her research.
Absolutely. She's even testified in court cases, helping juries understand how eyewitness testimony can be unreliable.
Because our memories can be so easily swayed.
Right. One of her most famous studies involved showing people a video of a car accident.
Okay, I think I've heard of this.
And then she asked them how fast the cars were going when they either hit each other or smashed into each other.
Ah, so the wording is the key here.
It is. And it had a huge impact on what people remembered.
Yes.
Those who heard smashed estimated much higher speeds.
Wow, just from that one word.
Yeah. And a week later, get this, they were more likely to remember seeing broken glass in the video.
But there wasn't any.
There wasn't any.
So, just by changing the wording, she actually changed their memory of the event.
It's incredible and kind of scary if you think about it.
Yeah, if something that subtle can change our memories, what else can?
Right. It makes you wonder how much of what we remember is actually true.
And how much has been, like, rewritten over time?
Exactly. And, Loftus didn't stop there. She even managed to implant entirely false memories in people.
No way. How is that even possible?
Well, she did it with Alan Alda, the actor.
Oh, wow, really?
Yeah. During an interview, she cleverly suggested that he had gotten sick from eating hard-boiled eggs as a child.
Okay.
And guess what? He started vividly remembering this event, even though it never actually happened.
You believed it.
He totally believed it. It became a real memory for him.
That's wild. It's like, if we can be convinced of something that never happened.
How can we trust any of our
All
memories?
right.
Exactly. Another one of her studies, they planted a memory of getting lost in a shopping mall as a kid.
A mall. Okay.
And a surprisingly high number of people ended up believing this completely made-up event as a genuine childhood memory.
That's incredible.
I know. And it's got huge implications, right? Especially when you think about how much we rely on memory in things like court cases.
Eyewitness testimony and all that.
So it seems like our memories aren't just these recordings of events.
Not at all.
They're more like stories that we construct and reconstruct over time.
And those stories can be influenced by all sorts of things.
Exactly. Our emotions, our expectations, the way we're asked about something, it can all change the story.
Makes you think twice about what you think you remember, huh?
It really does.
Hmm.
So we've talked about how our memories can be kind of unreliable. But what about the way we perceive the world in the first place?
Perception. Interesting.
Is seeing really believing? We were just talking about how tricky memory can be.
Right, how it's not always reliable.
But what about our perceptions? What we see, hear, smell, all that.
Oh, perception. That's a whole other can of worms.
Is seeing really believing? I mean, do we really experience the world as it truly is?
Not necessarily. What we perceive, what we think we see and hear, it's actually a construction that our brains create.
A construction.
Yeah, think of it like this. Our senses, they gather information, light, sound, all that.
Right, the raw data.
Yeah, exactly. But then our brains have to process that data, interpret it, and create a model of the world around us.
So it's like our brains are building a virtual reality simulation.
Kind of. But here's the thing. Our senses have limitations. We don't actually pick up on everything that's out there.
Like, I remember learning about the electromagnetic spectrum and how we can only see this tiny little sliver of it, what we call visible light.
Exactly. There are all these colors beyond red and violet that we're just blind to.
It's mind-blowing when you think about it.
It is. And there are reasons for that, too. Our ancestors, evolving in forests, the colors they needed to see to find food, those became the ones we're most sensitive to.
So our perception of color is literally shaped by our evolutionary history.
Absolutely. And it's not just color. Our hearing is limited, too. We can only hear certain frequencies.
Like, dogs can hear higher pitched sounds than we can, right?
Yeah. Exactly. That's why dog whistles work. We can't hear them, but dogs can.
And some animals, like bats, they use echolocation, right?
They do. They send out these high-frequency sounds and then use the echoes to build a picture of their surroundings.
Like they see with sound.
It's incredible. And even smell, something we might not think about as much, it's got limitations too.
Really?
Oh, yeah. Natural gas, for example, it's actually odorless.
Odorless.
Yeah.
But you always smell gas leaks.
Right, because they add a chemical to it so we can detect it.
Wow. So without that added smell, we wouldn't even know there's a gas leak.
We'd be clueless. It's a good reminder that our senses, they're not perfect. They give us information, but it's not always the full picture.
So our brains have to fill in the gaps.
They do. They use assumptions, prior experiences, all sorts of things to make sense of the world.
But sometimes those assumptions can lead us astray, right?
They can. That's where perceptual illusions come in.
Like the Ames room.
Exactly. It's this distorted room that messes with your perception of size and distance.
People look like giants or tiny people, depending on where they're standing.
It's a classic illusion. Shows how our brains rely on cues to judge size, and when those cues are messed with, our perception goes haywire.
There are auditory illusions too, right? Like that one where the tone sounds like it's constantly descending.
Oh yeah, the shepherd tone. It's trippy. It feels like it should reach a bottom, but it never does.
It messes with your head.
It does. It plays with our expectations of how sound should behave.
So all these illusions, they show us that what we perceive isn't always an accurate reflection of reality.
They show us that perception is an active process, that our brains are constantly constructing our experience of the world.
It's like we're all living in our own slightly subjective realities.
Yeah, that's a great way to put it. It's mind-boggling, but also really exciting.
It is. So we've gone from learning to memory to perception. We've explored how our brains make sense of the world, how we learn, remember, and perceive things.
And how those processes aren't always perfect, how they can be influenced and even tricked.
Absolutely. It's been a wild ride.
It has.
Thanks for joining us on this deep dive into the human mind.
Always a pleasure.
And until next time, keep those brains buzzing.